The broadcast is now starting. All attendees are in listen-only mode.
Hey, good morning, everybody, and this is Dr. Mansour, and today is June the 21st, and according to the schedule, this is Sunday, 6/21, and we are talking about transportation today. This morning, this afternoon, I will be in seismic. By the way, seismic, I have a class from 1 to 5, but it's different ID. If you'd like to join me, the seismic, for the seismic class from 1 to 5, I will be glad to provide you the ID if you are interested. But this morning, we are going to spend the morning with you guys talking about the transportation. The last meeting, it was last Sunday, and I scanned, it was the 14th of June, and we covered whatever we covered. And I scanned all these things and I send it to you. I hope that all of you received it, including the problems that engineering economics problems. We talked about the two problems in this quiz here, if you remember. And I send you the quiz again, a blank one, and some problems from the NCEES. And I also attached a total of, I believe, 20 something. Yeah, 20 problems. 20 problems. I used to cover these with the FE or the EIT group. So you are very welcome to look to these problems with the solutions. If you have any question, you are very welcome to ask. I hope that you get a chance to go over them. And I believe if you finish all of them, I consider these set of problems a very good preparation for the problems you might see for the transportation PM, transportation in the afternoon. And I tried for every single problem, I tried to draw the cash flow diagram, which I encouraged everybody last time to draw the cash flow diagram first, and after that, I tried to work it out. And as you're aware, that not necessarily the solution I'm providing here is the only solution, because engineering economics problems, we could have more than one way of doing it. So please go over these things and all these problems with the solution or with the solutions, and after that, please let me know if the depreciation, capitalized cost, a lot of problems, equivalent uniform annual cost. I believe very good set of problems. Probably, in addition to this set of problems, it would be helpful if we can, and I will do my best. I do have some problems related to benefit cost ratio, because they might ask you about that. So this is a target area, that the benefit cost ratio it might be an area that I encourage you to remind me or um, um, do it in your own, but I will do my best to include some problems. And I believe I have some problems included already. So today is the 6th, 21st, 2020, and this is a transportation PM. What is my calendar? Double check one more thing. Just to make sure that uh, so today is the 21st. No, we still have one meeting for transportation. I believe I added this to make up. I believe I missed one meeting, if I'm not mistaken. So the 6/27, 2020, which is next Saturday, from 9 to 12 a.m. or from a.m. to noon time. This is a transportation PM. So this will be so. We still have one more session, which is coming next Saturday. So next Saturday on the 27th, from 9 to 12 California time as usual. This is Pacific Standard Time. Pacific time. So you are very welcome to join me again next Saturday for the last session of the transportation. And after that, we are going to start the classes. Already I send you the brochure for those who are enrolled in the spring semester, and we stopped where we stopped, and because of this corona issue, and we will continue or we will resume teaching the class again, or I will resume teaching the class again based on the schedule shown on our website. So this is what but for the free, yes, the free I will keep teaching this free until we see what the courses, all civil courses, so construction, transportation. So I believe the first day is July the 5th, if I'm not mistaken. Yeah, here it is. Yeah, bear our schedule July the 5th. This is right now, this is a course. Okay, this is a course that will start again. And for those who are enrolled in the spring semester, automatically you will receive the ID. So the ID will be sent to all of you for those who are enrolled in our classes. Those who are going to join me the first time, also they will receive the ID and they will receive the books and so on. Okay, so this morning also, just yesterday, for those who attended the AM class, and I said that I would like to cover this chapter, materials chapter, the one I use it for the FE, the CBT, which is a very good chapter. Um, uh, and I scanned it yesterday. I sent it as a scanned document, but the quality of scanning for some reason didn't come out. I don't know, is a copy machine or the setting need to be adjusted. I will check with the people who are fixing my copy machine to make sure. But this morning I sent it as a PDF. So this chapter was sent to all of you as a PDF. You are very welcome to print it and um, and when we meet for the civil, for the AM portion, I will go over the chapter. The chapter has a lot of problems, and I need you to be ready. So when we meet with questions or comments or anything that you want me to cover. So this has been sent to you, so you are very welcome to print it. And I think we are going to meet July 4th, if I'm not mistaken, for the last 7 a.m. is going to be July the 4th, which I mentioned also from 1 to 4 using the same ID. So July the 4th is going to be, that's correct. Yeah, I check my calendar because I have too many classes. I try to do my best here. Okay. Okay. So let us move on since we already. Um, um, so last time I started talking about pavement, and I talked about the LE um, F, the load equivalency factor. If I remember correctly, let me see the last note I wrote here. This I did not include it here. No, I did include it. Yeah, here it is. This was the last sheet last time. The flexible and rigid pavement. AASHTO, they came up with the LEF, load equivalency factor, based on load tests, and they consider the 18 kips is the criteria or the reference or the datum, if you like to call it. So the 18 kips, okay, or the 18,000 pound is the reference uh, load that AASHTO considered uh, uh, in developing this LEF, load equivalency factor, okay, or factors. In fact, we have four. And as I indicated last time, there are 18 tables from an appendix D of this AASHTO document, the one I showed you last time. It's the green book. I can show it to you again. From D1 to D18, I used to have all these tables in my previous edition. This edition, I included only the one for B sub T of 2.5. So I did not consider the all the B sub T, the 2 and 2.5 and the 3. Um, so this is where we stopped last time. And as I told you that based on the 12 references, because as you know, you have 12 references for the transportation PM, 12 references and references. And I try to always update and correct and enhance my books based on these 12 references, based on the NCEES list of topics. So according to the NCEES list of references, you have AASHTO, you have 2 references related to pavement, and you have 1 reference which from the Asphalt Institute. It is the AI, the 7th edition, of the Asphalt Institute, and the AASHTO has 2 references related to pavement and pavement design, and I refer to these references in my books, okay, since they are the references that should be considered in developing the exam for you guys. The chapter that's given in my book is given in chapter 8 of my textbook, which matching the NCEES, and the title of the chapter is Geotechnical and Pavement. And theoretically speaking, they're supposed to include 4 problems, which is 10% of the total 4 problems in the afternoon for the transportation PM. Okay, so I don't know if I promise that I will mail you something from here or not, but I could do that if I promise. I will. For those who do not have the book, I will be glad to do that. Um, um, so let's start and let's cover as much as we can from this topic, and also I will scan it and send it to you today, and let me know if you are not receiving my scanned document. I will be glad to send it again, just simple an email. Sometimes it goes to the to the spam folder because maybe the size of the file maybe is uh, alerting the computer to put it on the spam. So check your spam folder. If you did not find it and you did not receive it, just simple email to me and I will do all my best to send it to you as soon as possible. info@psp.com. So the asphalt or the pavement, let's start with the pavement in general first. Pavement, okay, and geotechnical and pavement, geotech, geotech and pavement. So the geotech aspect in relation to the pavement is basically to determine the physical properties uh, of the soil supporting the pavement and also uh, do the testing for the material that will be used to manufacture these pavements. So, for example, the first topic listed in the NCAAS is called sampling and testing. This is exactly what you see in the box here. This is what is listed in the NCAAS. And under sampling and testing, they are talking about the subgrade resilience models. It's called M sub R. We are going to see M sub R. M sub R lowercase or uppercase, by the way. Both of them, I saw both of them. So M sub R. So subgrade resilience modulus. And the subgrade resilience modulus, let me start with this, which is M sub R. The M sub R, this is under the geotechnical, M sub R, the subgrade resilience modulus. Okay. The intent from this process of getting the M sub R using the geotechnical techniques is to determine how strong the subgrade. What is the subgrade? The subgrade, this is a soil that will support or provide support to the pavement layers, whatever the number of layers. So layer number one, which we call it subbase, if we have three layers, and this is called base, and this is the top layer or finished layer. And this is normally the most expensive one. Okay. In case of HMA, the pavement, either the HMA, the asphalt, hot mix asphalt, or the asphalt to concrete, AC, either AC or HMA, normally the top layer is the asphalt. And the other two layers, the supporting layers. So uh, um, the M sub R, we need to determine what is M sub R. Okay, the subgrade. So the determination of the M sub R of the subgrade is really critical. And in the geotechnical field, they came up with testing, they came up with equations um, related to the testing that they have done, and they came up with some kind of empirical formulas in order to estimate the M sub R, which we are going to see some of them, okay, very shortly. So the M sub R, the resilience modulus, the subgrade resilience modulus. So the let me I'm looking for something here very quick. Uh, I just remember it, something in my head, too many equations. Okay. So the the purpose of doing this, I will answer you, my friend. Some of you is raising the hand. Uh, I will answer you. Just give me 22 seconds. So the purpose of determining the subgrade um, resilience modulus is to make sure that when we deliver the load from the tires of the vehicles in a form of e-cells, the equivalent single axle load e-cells. So this load will transfer through the top layer, through the second layer, the base, and maybe it go to the sub base if the sub base exists, and finally it will come here to the supporting soil. So the supporting soil, which you call it subgrade, it should be strong, capable of resisting this load that will transfer through the layers of the pavement. So if every uh, layer will transfer the load as it's supposed to, without the excessive deformation or excessive settlement, and it should go here. So in this case, we are in good shape. Okay. So this is the purpose, and I will show you a couple equations, but after I grab something from the discussion here. Uh, but yeah, I received some questions from you. Yes. Are we going to finish everything by next week? No, no. Next week, this is free, John. This is free classes. I'm not going to finish everything by next week. No, it seems that you are not following me. As far as your questions, I received your questions. Some of them are vague, some of them are written. I don't know, uh, and I will do all my best to answer them. But I'm waiting until the class starts in July 5th, okay, to answer them. Okay, but I cannot answer vague questions. If there is any vague question, something that you remember or somebody told you about it, if they are not clear to me, I will be feeling that I'm not really okay doing my job okay right. But no, next week this is all this. So let me repeat again. Okay, this is not the transportation class. These are free workshops to keep you up to date, and I covered the material that we covered, and after that we are going to start the class. If you join me, my friend, the class will start July the 5th, and we are going to start from where we stopped, and we are going to go over all the material. If you'd like to start over again with us, okay, for example, we stopped at the signalized intersections or the signal warrants, and we covered only signal warrants based on the MUTCD. I did not cover the signal from the other the highway capacity manual, the highway capacity manual. So this is not the regular class. No, this is not the regular class. As far as your question that you sent to me, yes, I still have them. Everybody send me a question or a comment or even a mistake or a correction. I compile all of them, and I'll be glad to discuss it, okay, when the classes start, okay? Okay, and if there is a problem related to any topic, I will discuss it with everybody, at least the maximum benefit will be. But if the question is not clear to me, I will ask you, I'm sorry, my friend, I cannot really do it because vague questions or incomplete questions or guessing questions will be very difficult for me to do that, okay? So I hope this is the answer to your questions, my friend, that you send it to me here right now, okay? So this is my statement. You're raising your hand. I don't know if you are still want me to unmute you to talk about. I don't know, either you or somebody. Let me see who is raising the hand. Oh, you already put your hand down. Okay, that's fine. Just to make sure that I answered you, my friend. No problem. No problem. I will do my best. Okay. So the going back again to the That's fine. As I told you, okay. As I told you, I received the question, but I don't have to answer them if they are not complete. If they are not complete, my friend, or vague, I cannot answer them. This is what I told you. You still needed that, I will do it. This is what I said. Yes, whatever I can, yeah, for sure, I will do my best. This is what I said, my friend. Okay, just relax and take it easy, and I will do all my best. Okay, but as I said that, let us focus and talk here about what we are talking about here. Okay, so but I need you to understand the concept very well, because the questions, if you still think, or this is a general statement, and I have a lot of friends, they did this in the past. If you still remember some questions from previous exam and try to write them and they try to answer these questions only and rely on that, this is not a good strategy. The best strategy is to understand the concept and solve as many questions as you can, and understand the concept very well, and the practice enough. I believe you will pass without any problem, like anybody else, okay, who passed, okay, in the previous, okay, sessions or previous years. So try to do your best, and I will do my best, my friend. Okay, no problem, no problem. Let's go back again to the discussion here. The M sub R, the subgrade resilience modulus M sub R, and the California bearing ratio CPR also is another parameter that we used in order to determine the properties of the soil. The R value, R is the resistance value, and field tests. Field tests, I do have something. I send it to the AM group, and the field tests. Also, you need to be familiar with the field tests, how they do the test, like SIF analysis, like um, slum test, CPR, how they can determine the California bearing ratio, and so on, because sometimes they can ask these questions to you during the exam. Um, um, uh, so the field tests are very important also to know how they perform a test, um, um, whatever test they are, but the purpose of the test and how they do the test, and so on. And as I said that I do have I used to have 2 DVDs, and they are available right now because most of the computers nowadays they don't have a DVD player. So we can email them to you, where we have the soil tests, okay, including what may be included in the pavement section, and a steel and concrete, steel plus concrete, steel and concrete testing. Those are the testing that we normally do for these materials in order to determine the properties to be used for the design. So I will be glad to I will ask my people who are helping me. They are helping me from home because they don't come to the office anymore, and hopefully I can get this to and send it to you as an attachment to watch them. They are really helpful, and those who watched them in the past, they were able to answer some questions related to the testing of these construction materials. So this is very quick. If you have my book, this is a chapter 8, as I mentioned. If you don't have the book, that's fine. I will be glad to scan this chapter or send a PDF if you are not having my book. They came up with some empirical formulas. And these empirical formulas provided by Ashton, after a lot of testing and empirical formulas, basically it is a correlation between parameters. And this is, for example, one of them, the M sub R, okay, and the CBR, California bearing ratio. So if we know the California bearing ratio, as we're going to talk about it in just a minute, you can estimate the M sub R which is an equation to correlate the resilience modulus and the CPR, California bearing ratio. So they came up with this equation after a lot of testing. Another equation that the R value, the resistance value. Okay, the Asphalt Institute also proposed another equation, and it is listed in the ASH2 book, by the way, as equation 1.5.3. And this is another equation, and I give them these two numbers here. So these equations could be used in order to estimate the M sub R. Here I talk a little bit about the M sub R, by the way, the subgrade resilience modulus, the elastic properties of the for the unbound paving material is most commonly characterized by the term the M sub R, and a little bit about the M sub R and how. Okay, the California bearing ratio CPR. Again, another test developed by the California Highway Department and still accepted. The so the California bearing ratio is a penetration test where a standard piston having an area of 3 inches square is used to penetrate into the soil at a rate of 0.05 inch per minute. The pressure at each 0.1 inch, 1/10 of an inch, okay, is recorded, and its ratio to the bearing value of a standard crushed rock termed as California bearing ratio. This is a very brief discussion how the California bearing ratio is done. There is one document, we have it here in California for the Highway Department, in the Highway Department Materials Lab manual, how to go over this process from A to Z. California bearing ratio, you can search it. If not, let me know and I can send it to you if you need to get the entire test, but I need you to know. So basically it is a penetration test where they apply a load. There is a plate, and this plate it does have an area of 3 inches square, and they apply a load P, and this plate will be penetrated into the soil. So they take the penetration versus the load as indication, okay, to determine the California bearing ratio. Again, this determines the properties of the subgrade soil. There is another number here, is called soil resistance value R. The R value is the resistance value of the soil determined by stabilizer. Stabilizer, this is also an instrument, okay? Stabilizer test, okay, was developed by the California Highway Department and measured basically the internal friction of the material. Also, there is a complete test, okay, for the R value, a very good table or a figure, as you can see here, is developed in order to correlate too many properties or many properties of the soil. And the title of this is called Approximate Relationship Between the K Value, and you will see what's the K value in just a minute, okay, and other soil properties. K, we use K a lot, by the way, in many other equations, but the K here is called the subgrade reaction K. So the modulus of subgrade reaction K, or the, is a primary performance factor, okay, for the soil, and its unit, okay, in PCI pound per cubic inch, by the way. It is PSI per inch, but we pronounce it as pound per cubic inch. It is determined from the loading test of a circular, okay, 30-inch, where, okay, the deformation versus load is determined. So this is called B delta curve, and whatever the B delta curve is, and we take the slope of this line, if it is a line, or we draw a tangent to determine the slope, and the K is equal B over delta. This is like the spring stiffness, if you remember in physics, 4A or 4B, whatever physics class you took. So what they did here, this is a subgrade K reaction K, and you will see this, all these numbers, by the way, you will see it in nomographs. The ASH2 and the Asphalt Institute, they developed nomographs in order to come up with the design. And the nomographs, you will find that it has all these parameters, as we're going to see later on. So this figure here, which I call it figure 3 in my book, This, it came from PCA, Portland Cement Association. Is another organization also. They have a lot of testing, and PCA, by the way, BCA, they have one reference, by the way, among the 12 references. Let me see what I have here. Uh, I use this reference. What was the first edition? Right now they have it, the 16th edition. Okay, I don't have the 16th here in front of me, but PCA, Portland Cement Association, they have a very good book. It's called Design and Control of Concrete Mixtures. This is published by the Portland Cement Association, PCA. And right now, the current edition is the 16th edition. So if you go and look to the references, the 12 references, you will find that the 16th edition is one of the references. Again, is a very valuable book as for concrete mix design and the properties of concrete. And as I mentioned, probably you have me before saying that I used this book way back in Las Cruces, New Mexico, when I was teaching there, and it was the first edition way back in 1983. In 1983, when I started to teach this subject, it was the first edition. But from now, from 1983 now until now, they included all these editions. So the key value, they develop it, BCA, they develop it as follows in relation to or correlate this key value to other properties. Like what? Number one, the ASTM soil classification, and this is Unified Soil Classification System. If you remember, we talked about Unified Soil Classification System, USCS, where we have the, for example, SP, SM, GB, and so on. If you remember this, G for gravel, and S for sand, and C for clay, and silt, they are using M. So those are the 4 letters that we are using, or they are using in the Unified Soil Classification System, and they add another letter next to it. For example, GP, as indicated here, this is poorly graded gravel, for example. SW, for example, is shown here, SW, which is a well-graded sand. So the P for poorly graded and W for well-graded. So and so on. Okay, so this is, we cover this for the AM, by the way. And I don't know if I also elaborate on this here or not. I believe sometimes I do this just to remind you with the properties. If not, because some of you are not taking the AM with me, I would be glad to talk about that. So this is the Unified Soil Classification System, USCS. The second correlation between the K value is the ash to soil classification system. Okay, this is the A system, ash to soil classification system. We call it A system, from A1, which is being the best soil, to A8, which is the worst soil that can be used to support pavement. So they have A5 and then a subgroup, by the way, and A1, A2, and so on. So these 2 systems, I cover them in depth with the AM group, and I would be glad to cover it here with you also. So also the PCA, they came out with something, Federal Aviation Administration Soil Classification. I don't cover this at all. I don't cover this at all here, and it's not required. Okay, so the Federal Aviation Administration Soil Classification, they are not really covered in this class, or the AM also. The R value, yes, the resistance value, the modulus of subgrade reaction, which is the K, the one I just mentioned, okay, and the bearing value, and finally California bearing ratio, CPR, California bearing ratio. So the purpose of this chart, that I can estimate, okay, or I can get the soil type based on the K value, the relationship between the K value. If the K value is known, in this case, I can um, estimate the other properties or get the other properties. Okay, so this is the K, which is P over delta. And again, the P is the load and delta is the deformation, B delta curve. Okay, and the slope of the line is a K. Okay. Also, there is a correlation between the M sub R, the resilience modulus, and the K, and is given by this equation as given in the Ashto book. And after that, they develop some values for us. The untreated sub-base K value and the cement treated sub-base K value. So cement treated or untreated. So if I know the subgrade value, whatever the value, I can determine, okay, how much value I'm going to get. It depends on the thickness of the sub-base thickness, 4 inches, 6, 9, and so on. So in this case, I can determine how thick the pavement, okay, should be in order to develop certain properties to resist the load that's coming from the easels. Okay. Field tests, this is something, as I told you, that I will be glad to send the testing that I have. And you are very welcome to watch the 2 movies, okay, one, in fact, 3, one for steel and one for concrete and one for soils. And hopefully that this will help you. For example, talking about what is a standard penetration test, SPT. They will show you how they perform the standard penetration test in the field and what are the results that can be obtained or can be developed from standard penetration test. What about the cone penetration test? Okay. Also, they show you how to perform the cone penetration test in the field and so on. So I needed to be aware of the testing because sometimes they can ask these type of questions on the exam. So this is like a reading. I'm not going to read this here because I need you to focus more on. So all this is the reading for the testing and so on. Let me go because all the and compaction, this is also reading. I talked about mass diagram here, and I believe I killed it to death. This is also based on this chapter, the mass diagram. I have this table here, which is the swell factor and shrinkage factor and the properties and so on. And this figure, I came up with this figure, okay? And as I mentioned before, I need you to remember this figure very, very well in order to be able to answer many questions related to the volume or the earthwork and so on. And I will repeat again this diagram, which is this is a bank cubic yard. And this is the loose cubic yard. I know I draw this about 10 times, 15 times, compacted cubic yard. So from here to here, as I mentioned before, is called from bank cubic yard to loose cubic yard is the swell factor. And we said the swell factor is 1 plus a swell percent. And from here to here is the shrinkage factor, which is 1 minus a shrinkage percent. And the swell factor normally greater than 1. Shrinkage factor is less than 1, except for rocks. This is for silt, clay, and so on. So if you are able to remember these conditions of the soil could be exist in the bank as exist before disturbance. After we disturb it, became a loose, and after we place it and compacted, became a compacted cubic yard. And the famous figure that most of the geotechnical books and construction books, they have it, is here is a 1 cubic yard which is bank cubic yard, and this is the loose cubic yard, LCY, and this is a compacted cubic yard after we place the soil. So I need you to be aware of that, okay? And this table also is available in all my books. So be ready for the mass diagram, because I believe the current edition of the NCEES, they have a problem, and they probably will solve it together if I remember correctly. This is the transportation book, the blue book, and there was one problem at the end of the book, if I remember correctly, end before end, or this edition, or yeah, here it is. This is the problem that we solve it together. If I remember correctly, problem 5 in the blue book, 537. He gave you a table. If you have the book with you, I think all of you have it. Um, and as I mentioned, I am following up with the NCEES. If they are coming with a new edition, I would be glad to order if they are going to come up with a new edition. I don't know. Last time I checked, I didn't see any new editions on the horizon or on their pipeline, unless somebody can correct me if I'm wrong. And we should be able to do that. We should be able to do that. So. So this is something, okay, I needed to be aware. So the mass diagram is important, and uh, and um, um, please let me know if you have any mass diagram. And already I covered this in the AM. I covered also with the construction group, and we solved many problems together. If I remember correctly, we solved many problems. Um, and as a quick reminder, I can come up with something. I don't know if uh, and be ready, because every time they come up with something that uh, never exists before, uh, as far as the type of questions. But if you are able to, or if you, sorry, if you understand the concept very well, I believe you will not have any problem, and you will be able to solve uh, any mass diagram problem. For example, if hopefully I can come up, if this is a station, and the station normally starts whatever the beginning of the job, and we can say that this is, let us make this a quick problem, and you promise me that you are going to solve it. So this is station 1 and 2, 3, 4, 5, 6, 7, and 8. And let us make some volumes here. Okay, so it is 1,000, 2,000, 3,000, 4,000. It's assuming that we have a mass diagram like this. Okay, so I just made a problem, try to draw it as accurate as I can. Okay, so Here we go. Okay. So if you look to this, and I'm going to get close as much as, okay, so this is the commutative volume. Normally the y-axis is a commutative volume. Commutative volume. Even if they didn't mention that, they say just volume only, you should remember that this y-axis or the ordinate is a commutative volume. And the commutative volume, it could be a cubic yard or a cubic meter. And it could be either bank cubic yard or bank cubic meter, it could be loose cubic yard or compacted cubic yard. So any status of the cubic yard or cubic meter could be stated on the y-axis, either compacted cubic yard or loose cubic yard or bank cubic yard. If he asks you to calculate, this is, here it is, and I try to make the drawing like a grid for you. At least you can see the stations, and here it is. So if you look, this is 1,000, 2,000, 3,000, 4,000. Okay. So okay, try to make my critical points very obvious to you at the stations. So the station 6 and this is station 4 and this. Okay. As you can see here, we have some high points and low points. Okay. So, and as we talked about this before, the high point is a change from cut to fill, the low point from fill to cut. Okay. Based on this drawing, or bear this drawing, or according to the given mass diagram in front of you, they can ask us tons of questions, tons. Okay. So, but let me get this question here from one of you. Let me see if I can get it. Let me take it one at a time. So Alex is asking, can you please, okay, send us this chapter? I will do my best. I will do my best. Yes, Alex. Okay. Ray is asking, for instance, okay, if you use figure VI-3, what would be the answer to a subgrade soil with a CPR of 8? Estimate the value. Okay, so if we go back again to the figure, sorry, my friend, okay, let me go back again to the figure and see if, okay, so if the, you are telling me that if the K value is given, okay, so if the K value subgrade with a CPR of 8, estimate, okay, so if the California bearing ratio of 8, okay, and let me array, and you would like to get the resilience modulus, okay, let me move it. Let me move this here, at least I can answer you, my friend, and I will use a straight edge. Normally take a straight edge with you, okay, if you can. So this is the CPR of California bearing ratio, which is the last column here, last row, sorry, it is 8. And if I will go vertically from here, okay, and draw this line all the way to the top, here it is. If I go from California bearing ratio 8, like this, okay, and if you ask me about the R value, Okay, so the R value is 40. If you ask me about the K, so the K, this is 150, and this is 200, okay, and this is 250. Okay, be careful, these are not regular scales, so it's not really okay. So we have to be careful a little bit. Okay, so this is 50 and this is 150, sorry, and this is 200 for the K. So in this case it is I will try to use as much as I can, as far as, because it's not linear. As you can see, this is from 150 to 200. So I can use a straight edge, and I can use, okay, how many millimeters here and how many millimeters and the proportion. So probably this is probably close to about 180. Probably I will go 180, something like that. But I will use, in a case like this, I will use a straight edge, and the straight edge has, this is the way I do it. Since it's not a regular scale. So I count, for example, I use a straight edge like this, and it has small divisions, either inches or millimeter. I see how many millimeters is that. Okay, so this is 20. So this is 20. Okay, so this right now, this is 20, and this line here is 13. So I will say 13 over 20. So 13 over 20. Okay, 13 over 20. And 0.65. 0.65 I multiplied by 50, which is the difference between 150 and 200, so 50 times. And I will add this to 150 plus, I ended with 182.5. So this number here is 182.5. And for sure on the exam, he will not really give you, okay, something they are very, very close to each other, because reading the graph itself. So this is the value for the K. For the bearing value, here it is, how many psi, the R value, and since federal is not, so this, okay, what type of soil it might be, this value that it has a California bearing ratio of 8, the number you gave me, Ray. So in this case, I can estimate, okay, what will be the soil group that will fit the bearing California bearing ratio of 8. I hope this is the answer to your question. So, and this is true for all values of any, if I have California bearing ratio, for example, of 25. So I will come here and I draw a vertical line, and this vertical line, okay, will take me, okay, and I can estimate the values for whatever value mentioned to me. Okay, I hope this is the answer to your question, my friend, in figure 8-3. Okay, so this is the first thing that let's go to the questions one more time, just to make sure that this is what is meant. And so Alex, you told me that you sent it. Ray, already I did my best to answer the question. Can you this mean that is only fill? This diagram means it is only fill. If you are talking about the mass diagram, that the one I draw, this one here, let us ask the questions, and let's come up with the answers, and after that you will I will comment on your answer, or your question, sorry, will be okay. So let us look to this diagram here. Okay, this diagram here, and as I said that so the first question that I can ask, or can be asked, the y-axis, this is a cumulative volume, and this is stations. I have from station 0 at the beginning, and this is 1 all the way to station 8. Metric or English is not a big deal right now. And this, let's assume this is US. So the first question I will ask, question number 1, related to this mass diagram. Okay. What condition exists for this project. And I meant by that these four answers here. Answer A, that uh, cut is greater than fill. Then fill. Answer B, I will opposite. I will say fill is greater than cut, which is answer B as a boy. And answer C, that the cut equals fill. Or answer D, insufficient information, or none of the above. None of the above. Okay. I know maybe the exam they don't have none of the above. Say that insufficient or insufficient information, insufficient when insufficient info. If you like, if you hate the none of the above. So this is a question that it might be asked, and if you can select the answer that you feel that is appropriate. The second question can be asked to this, that the total cubic yards, assuming this cubic yards, or the total volume in cubic yards, to be hold slash moved. Okay, so the total volume in cubic yards, okay, in cubic yards, okay, to be hauled or moved over the entire length of the job, over the entire length of the job is most nearly. Okay, and I will say answer A, it is 4,000 cubic yard. Okay, and answer B is 3,000 cubic yards. Answer C is 5,000 cubic yards. Answer D is only 2,000 cubic yards. If you'd like to put them in order, I have no problem with that. I can put them in order. Okay, from larger to smaller, I have no problem with that. Or you can keep it like this. Sometimes they do that. Sometimes they keep them in order. Sometimes they mix them. So we need to be ready for. So this is the question number 2. Okay, let me move my camera here. Or let me move my drawing here, and I will zoom a little bit out, or I can move my camera a little bit up, and I will give you 2 minutes. Here we go. I think I am able to put, and let us put this piece of concrete here just to hold the paper, or I can get a tape to tape it, but here it is. What about that? Question number 1 and question number 2. And after a few minutes, we can vote. We are a democratic country. We are going to vote November 3rd. I was telling them yesterday, probably heard this song from me before. Okay, so, and let us see what. These are 2 questions I can generate. I will generate more as if we answer these 2 questions, the other questions, obviously, it will be very very easy for you to figure it out. Or, okay, let's start now. It's about 10:10. Let's come back after 10 minutes from now, 10:20. If you like to keep working on these two problems, select an answer, A or B or C or D, and we are going to meet after 10 minutes from now. Thank you. Okay, welcome back, everybody. Okay, so it is 10:20 right now. Let us see the voting. For question number one, what condition exists for this project? What is the condition of the earthwork activity or the earthwork of this job or for this job? That the cut is greater than fill, C greater than fill, or the fill is greater than cut, which is answer B as in boy, or both of them are equal, or the fourth answer, none of the above, or insufficient information, or insufficient data, or he can come up with another answer here. Okay, I can come up with, for example, the cut is 3/4 of the fill, or the fill is the 3/4 of the many ways that can be address this question. So since we are a democratic country, so what is the answer for question number one? Let me see. I am not going to call your name. Tell me A or B or C or D or I need an answer, either A or B or C. Okay. Okay. So we got very good answers or many good answers. So in this case, we can say that the cut and fill are equal, and this is the correct answer. Okay. So this is, so basically, the cut and the fill are equal. And you can tell directly from this by, we started at 0 cubic yard here and went up and down and up down, and I ended back again here at station 8. I went back to 0 here. That means that the cut and the fill are equal. Or he can, instead of saying that this answer, he will tell you the job is balanced job. Balanced job. Okay, so he can say, instead of stating cut and fill are equal or cut equals fill, he can say the job is balanced, which is mean the same thing. Okay, if you look to the second question, question number two, the total volume in cubic yard, the total volume of soil, obviously, to be moved or to be hauled over the entire length of the job is most nearly. So let us look to see what question number two right now. What are the or what is the best answer? And they are looking for the best of the best. Okay. So right now we are talking about question number two. Let me move this here. Question number two, this one here. How many cubic yards to be hauled around the job or over the entire length of the job? Okay. One more time, let me check the answers just to make sure that I didn't miss anybody. Okay. So I got A and B and C. I got these answers, by the way. I got three answers. Nobody selected D yet. Okay, so D is not the favorite answer, or is not an answer by any of you. Okay. if you look to this project, you will find that, sorry, we have cut and fill. Sorry, I hit the my cup of coffee, so it came on the computer. I hope that it will not. If the computer start to smell from your end, this is my coffee, okay? So if the computer start to smell like coffee, that this coffee is coming from my end here. Just I need to dry it as soon as possible so the computer will not shut down. Okay. Okay, I think here it is. Okay, I don't know why. I just moved something and it hit the cup of coffee, so I don't know. So nobody will smell coffee from your end because we are not disconnected yet. Okay, sorry guys, just okay. If you look to the, I was trying to get some markers to highlight stuff, so I hit the cup. If you look to this mass diagram, the one I just came up with, you will find that um, we have cut and fill. And they agreed that the cut is a positive slope and the fill is negative slope. So from here, from the beginning, all the way to the top here, this is a positive slope. So this is cut. And as you know, this is a high point of the mass diagram, high point. So the high point is a transition from cut to fill. So the fill is coming down up to here. So this is a negative slope and this is F. And again, the cut will start to happening again from station all the way up to here. Okay, so this is also cut. And finally, the fill will continue to the end of the job from the high point all the way up to here. So this is also fill. So I have two high points and one low point. So this is still a high point, which a high point always a transition from cut to fill. This is a low point with transition from fill to cut. Okay, so I have two cut segments and two fill segments. And as you can see, the volume of the cut from here, this is a cumulative volume. So I generate 4,000 up to here. So I have 4,000 yards here. And when I start to cut again from 2,000, I hit 3,000. So it's another 1,000. And this is why the answer here is 5,000 cubic yards. This is the amount of the soil that to be hauled. Hold means hold moved. Hold or moved. They are using both terminologies. The soil is moved or over whole distance and whole distance and the free whole distance. So the word whole is very important. We have over whole distance, and we have a free whole distance. And we have what is known as the average whole distance. Average whole distance. All this over whole distance. The free whole distance. So these terms, they should be very clear to you. So based on that, you can see that the cut, I have cut, and after that followed by fill, and I have another cut, which is a positive slope, followed by fill. And this is why the job is balanced, because if you look to the fill from 4 to 2, So it is 2,000. And from 3 to 0, 3,000. So 3 and 2 is 5. So I have 5,000 yard cut and 5,000 yard fill. So this is why we are saying cut and fill are equal. And in this case, the job is balanced as we indicated. Okay, so I have 5,000 cubic yard of cut. And also this is a 5 cubic yard of fill. So these two volumes are equal. 5,000 and 5,000 cut and fill. Okay, so I hope this is a good reminder of the mass diagram, which I believe we talked about it a lot. I covered a lot, and the the equation that I provided in this chapter. Let me see here. The the equations that I provided in this chapter. It's called uh, um, earthwork mass diagram relationships and equations. Uh, Please pay attention to this because you might be asked about station yard, for example. Uh, what is a station yard? Station yard overhaul. Uh, um, it is the volume times the overhaul distance minus a freehold distance if any freehold distance, and this is minus. So so we need to be aware of that. A freehold distance is a distance agreed upon between the owner and the contractor, and it must be stated in the contract, but you cannot assume it. You cannot assume it. So freehold distance, which is this one here, freehold distance. This is a distance specified in the contract or in the specifications, if you like to use the term specifications. Okay, so this distance is specified in the contract or in the specifications of the contract, and this distance must be given. This distance must be given, not okay assumed. So I need you to be aware of that. That this distance it must be stated in the problem. If it's not given, we take it 0. So it must be given or stated in the problem. So I need you to be aware of that. So for example, the equation about the average hole distance, which is also, it could be a target for a question, came before more than once, as far as I know. The station yard overhaul, this is what I meant, station yard overhaul is equal the volume, the overhaul volume in cubic yard or cubic meter times the overhaul distance minus the freehold distance if the freehold distance is given. So this equation, it might be a target for a question, might be. Okay, I wish I know what they are going to ask, but unfortunately I don't. So for example, if you look to a situation like this, this is a volume, cumulative volume in cubic yard. And if you look to the x-axis, okay, so this is a station, and this is the volume. Okay, this is cut, and this is fill. This is another way that the mass diagram can be drawn, by the way. Okay, and instead of moving the station line all the way at the bottom. You can put the station line in the middle like this. You could see that also. And along the stations, for example, all these tick marks will be given to you as indication of what station is at, stations. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, for example, 10. Okay, and let us make some volumes here. It's for the sake of discussion. It is 2,000, 4,000, and the last here is 6,000. Okay, and let us take um, um, uh, um, just to make sure that I, okay, so let's assume that you have the following mass diagram. Okay, assuming this scenario is given, and when you receive, uh, we call this a loop. A loop consists of cut and fill. So if this is a cut, as we agreed, this is a positive slope, it's cut, and this is fill, okay, negative, and this is still negative, which is fill, and this is positive, which is cut. And the question that you might see, and this is 2,000, 4,000, all the way to 6,000 here. Let me get closer to the camera here. And this is 2,000, 4,000. So this is called a loop. This is a loop. And this is still the high point that we talked about, high point. And this is the low point. Okay. And this is cubic yard. This is a volume, obviously, cumulative volume, cubic yard. It could be loose or bank or compacted, whatever. And the question that related to this mass diagram, it could be like this. The station yard overhaul, the station yards overhaul is most nearly. And I'm waiting for 4 answers and see. So the station yards overhaul, okay, let me move my camera a little bit up, a little bit or out to accommodate the picture, and here it is. So the station yards overhaul is most nearly. Station yard or yard, some books they call station yard overhaul is station yards. If you like to make it a singular like this, is still acceptable. Station yard overhaul or station yards overhaul is most nearly. for this job. So I have 2,000, 4,000, 6,000 here. This is still low point, which is changing from cut to fill. Okay. Okay. This is a transition point, by the way. This is called first balance point. This here, we call it second balance point. So we define this is called a loop, and this is called a loop. So I need the station yard overhaul is most nearly. And I will give you about 5 minutes because it might need some time from you to come up with the answer. And hopefully that my Egyptian handwriting is readable to you guys. Forgive me, sometimes I write from right to left, but today, no, I was not practicing that. So you can, yeah, I always try to improve my handwriting in order to make sure that you really can read it easily. So I need a station yard overhaul. Okay, let us gather or collect some answers from you guys and see what who is the winner today. And as I mentioned yesterday, the winner will take me to lunch. Oh no, I will take him to lunch, him or her. Okay, so let's get some answers. Okay, you are counting the jokes. That is one joke. Okay. Oh, I am serious. Oh, okay. Thank you. Okay. Our friend is counting. Probably he remembered the joke. I told him that uh, at the beginning of each semester, for 30 years of teaching, I always tell the students the first day I know only 15 jokes. So I told them, guys, I will tell you all the jokes. I will spell all my jokes one time, and I'm numbering them from 1 to 15. And in the future, if I feel that you are sleeping, I will tell you joke number 6. You should remember what joke number 6 is. Okay. So anyhow, so yes, thank you very much for counting my jokes, my friend. Okay, now I am getting different answers and different numbers. And um, uh, uh, I got 10,000, I got 25,000, I got 4K, I got 100 station yard overhaul, 100. So I got, let me put them down here first, 100 station yard, and I got 4K, which is 4,000, I believe, K for 1,000, and I got 10,000, and I got as high as 25,000. I can answer. Somebody is giving me 15,000. Oh, discount. That's good. A, B, C, D, E. So here it is 15,000. Discount from the 25,000. 15,000. Okay. Any other answers? So 15,000, 25, 10,000, 4K, 100, and 15 also mentioned before. Okay. So you mentioned 15 before. Okay. So we do have different answers, A and B and C and D and E. Okay. So uh, station yard. What is a station yard? What is a station yard? And this discussed also in my books. If you read the section about mass diagrams, let me make sure that I number my pages correctly. So this is page number 2 and page number 3. What is a station yard? What is a station yard? A station yard is defined as a volume of 1 yard or 1 meter, 1 cubic yard or 1 cubic meter. So whatever I say here uh, is applicable to both units, the US and the SI. So a station yard is a volume of 1 cubic yard that has been held one station. So if you have the magic truck, and I know some of you remember my famous truck. So this truck, it has, we put 1 cubic yard on it. In this case will be loose cubic yard, 1 yard. And this truck, it traveled a distance, 1 station. And since we're talking about cubic yards, so this is 100 feet. Station is 100 feet, as all of you know, using the US customary units. So if this truck that is carrying 1 cubic yard, it traveled 100 feet or 1 station, so we call this is 1 station yard. So far so good. If this truck is carrying 15 cubic yards and it moved 5 stations, which is 500 feet. So the result is going to be 5 stations times the volume, which is 15. So it is 75 station yard. Make sense? So the station yard is the product of the volume to be hauled, volume times distance. This is the definition that we need to remember or to understand what is meant by station yard. So far, so good? Okay. Having said that, we'll come to this mass diagram that I just generated for you. So I have two loops. I have this loop and I have another loop, which is the loop below the balance line or below the x-axis. So this loop here. I have two loops. And the loop above the x-axis or the station line or the balanced line, it is forward haul. Another term, forward haul. Why forward haul? Because the contractor is going to come and take the cut volume or the cut volumes, which is the left side. This is cut. This is C. And he is going to move the cut volumes to put it in the fill sections. And as you can see here, the cut is happening from this station, from the beginning of the job, all the way, probably the high point, I put it in the middle at station 2.5, between station 2 and the 3. So from station 0 to station 2 plus 50, I have cut. And from 2 plus 50 until station 5, I have fill. So the contractor is going to take from here and put it here. This will call it forward. Why forward? Because the moving or the hauling is happening in the direction of increasing station. This is in contrast with this loop, the one below. The cut is here. The cut is here. And the contractor is going to move the volume from cut to fill. Always, we'll move it from cut to fill, always. So it's going to move it. So this is why we call this is backward haul. So again, another two terminology or two definitions related to mass diagram, which is the forward haul and the backward haul. We need to know the difference between them. And already I defined what is the first balance point and the second balance point. So since I defined the station yard as a volume of 1 cubic yard to be hauled one station, the problem I having right now or facing me right now, the cut is happening over a distance from station 0 to station 2 plus 50. And the fill is happening from station 250 or 2 plus 50 until station 5. And the same story here. So the cut is happening over a distance and the fill is over a distance. So how I'm going to get this distance I'm looking for? How many stations? How many stations that the volume or the earthwork we're talking about or the volume we're talking about? So they came up with something in order to be fair to the owner and to the contractor to a term is called average haul distance. average whole distance. What is the average whole distance? Average whole distance is a distance that the material will be hauled from cut to fill. They add the word average to say, here it is, I have a cut and I have a fill. This is cut and this is fill. And this is the high point. So the cut is happening over this distance from whatever station to this station. And the fill is happening from here to here. So they said that to be fair, let's come up with the center of mass of the cut and the center of mass of fill. So this is the cm center of mass of cut, and this is the center of mass of fill. And if we take this distance from here to here as the average whole distance, so I know what station this station, and I will come down to know this station, this, what we call it, the average whole distance. Are you with me? Or you are thinking about the stock market tomorrow? What the stock market will do tomorrow is going up or down? Don't worry about the stock market. Just focus on your PE, and the market will take care itself, or take care by itself, or take care of whatever is. So the average whole distance. So if we are able to get the average whole distance, because as I told you, the cut is happening from here to here. So shall we take this distance from here to here? So they came up with this, center of mass to center of mass. CM stands for center of mass. You remember center of mass? For we cover this in dynamics, we cover this in statics, we cover this in seismic design, center of mass and center of rigidity. For those who took this seismic class and they remember that center of mass. So in my scenario here, I need to know what is the average hole distance for the loop above and the average hole distance for the loop below. And I will multiply the average hole distance times the volume, get the numbers, and that's it. Okay. So how can we determine the center of mass and the center of mass? There are two ways to get the average hole distance, which I explained them before about 2 times or 3 times. This number 4. For those who are taking the class regularly, they heard this song from me before. For those who are here today the first time, this is the first time you hear my song. And after the end of this class, you can tell me if my voice is good or not, the song is good or not. I don't know. I always joke because, as most of you that you know that I'm Egyptian, and I mentioned the word Egyptian more than once. There is a song, it's called Walk Like an Egyptian. I don't know if some of you heard this song or not. You can Google it tonight or search it on YouTube, Walk Like an Egyptian. So when you see somebody is walking in front of you, you can tell if he's Egyptian or not from the way that he walks, the way he walks. Okay, so how can we do that? How can we get the average whole distance? So there are 2 ways, graphically or mathematically. Graphically, we come to the high or the low point and draw the vertical line, which is the ordinate, and come at the midpoint MP, which make, and they draw a horizontal line to go through the midpoint, come down, take this station, take this station. The difference between these 2 stations is given to give you, so this is graphically. So using the midpoint point concept. Mathematically, we are using the area under the mass diagram. I need you to know, and I mentioned this, I believe, here, that one equation, that area under the mass diagram curve is, in fact, it is a hole or work. So the area is representing the amount of work or hole. So mathematically, you can get the average hole distance by doing the following: is equal to the area under the mass diagram divided by the volume that will be held. And theoretically speaking, they're supposed to give you the same answer, by the way. They should be giving you the same numbers if you did. So if you look to this, I can use the area over the volume, which is mathematical solution, much faster and easier. So here, I can get the average hole distance for this first loop here. In our case, this was 6,000. And this was station 0, and this was station 5, plus 0, 0. So here, the average hole distance is equal to the area, which is 1/2. The base is 5, and the height is 6,000, divided by 6,000, which is a maximum volume. So this will give you 2.5 stations. I will do the same thing for the loop below, which is this loop here. So I will say that what is the average hole distance is equal 1/2 base. This from here to here, and this is symmetrical. You can get this very easily. But if it's not symmetrical, I will use this concept, because this concept. So it is 5 times 4,000 divided by 4,000. So this will give you also 2.5 stations. Due to symmetry, we got. So I have 2.5 stations and 2.5 stations. I have here 6,000 cubic yard. I have here 4,000 cubic yard. So the answer to this question number 2, which is the station yard or the total station yard is equal to the volume 6,000 cubic yard times the average hole distance 2.5 stations, sorry, plus the second volume, which is 4,000 cubic yard times the 2.5 stations. So this will give you 25,000 station yard. And this is the answer. And I got only one answer from you, Sam. I believe Sam is the one who gave me the right answer, if I remember correctly. Oh, I said that I'm not going to mention names. I'm sorry. Okay. One of you, I don't know who is. Okay. So this is the way we calculate. So the correct answer is answer D, as in doctor or dog. Okay, so in this case, we need to be aware of that, because we need to. Okay, please look to this, and I will be glad to go over this again next time when we meet, because as I said, that we are going to meet again on the 27th of this month. One table here. After you receive it, look at it and correct me if I'm wrong, or if you disagree. As I always say, please don't take me to court. We can resolve our differences here, because I hate going to the court. there is one table, you will find it in my book also. And this table is not my invention, or all the information in my books are not invented by me. It's just materials. I present the material. I don't invent the material. The materials exist in textbooks and codes and so on. It's just a matter how to present it. And like your professors in school, two professors, they are using the same textbook, but everybody is presenting the material differently. And this is true. They are using the same reference material, but they are presenting the statics or mechanics of materials or steel or concrete differently, because every professor has his own style and his own approach of doing the teaching methodology. So I hope that I'm presenting the material to you in a way that you understand it and understand the concept very well, because as I told you that you will go to the exam and you will see something never exists, okay, on any other book or any other books available in the market. But if I understand the concept, it doesn't make any difference. It does not make any difference. It does not make any difference, okay? So one table that presented in my book here, which this table here, I found it useful as far as construction materials or the soil specifically as one of the construction materials. The construction soil characteristics based on unified system, unified soil classification system, the USCS system, which is these symbols, that the one I was telling you about, G for gravel and C for clay and so on, and uh, B for poorly graded and W for well graded. So and these are the categories that I selected to be as far as the drainage. If we use um, silty gravel, okay, or clayly gravel, well-graded sand is excellent. Well-graded sand is excellent as a drainage material because the water can percolate and it can drain the facility very well. So I try to use this. Okay, as far as the construction workability, by the way, the term workability, if you remember in concrete, we use the term workability. What's workability? Workability, it can be in reference to uh, sand, and it can be in reference to, soil in general and concrete. So the term workability for soils or workability for concrete. For concrete, as you know, we have two tests to measure or determine workability. One is called the slump test, and the other one is called Kelly ball. And both of them will determine the workability of the concrete in inches. And workability is defined as the property of the concrete that will determine the ease of mixing, transporting, placing, and finishing. How easy is to deal with this concrete as far as mixing and transporting and placing and finishing the concrete. And the ACI code, they came up with a table, and this table shows what is the appropriate slum for each type of construction job or construction type. So when we're talking about the workability in relation to soil as indicated in this table, how easy to work with, okay? How easy to work with as far as moving the soil, compacting the soil, mixing the soil or put it in the proper location and so on. So this is what is meant by that. The following here is suitability for the subgrade. Subgrade. Suitability for subgrade, no frost action. Mean that frost action, this is the presence of the voids, and when during winter seasons, if the water entrapped in the voids frozen because of the harsh weather or because of the cold, it will increase in volume, as you know. So we need to know that. So suitability. Suitability for finally surfacing. Suitability for surfacing. Also, we need to be aware of that, because I believe there was a question in the NCEES in the blue book again, um, uh, in the construction, no, in the transportation section. Um, here it is. Question number 536. Which of the following soil grouping or groupings is the least likely to present embankment and settlement problems? Okay, we are building an embankment. Embankment means fill, as all of you know. This is the center line. This is fill or embankment. So he gave you gravel and sands, gravels, sand, organic silt, plastic silt, clay, organic silts, or organic soils in general, sorry, and clays. And the word least, okay. So if you look to high organic, high plasticity organic, and some kind of organic materials like beets, or low plasticity organic, and you compare it with the other. If you look to uh, to um, uh, gravels and sand, okay, so gravel and sand, so you have, it doesn't matter if it's poorly graded or well graded, you will find that the organic materials, you will find that they are either poor or fair, but or it could be, if it is high organic, you will find that it's very poor or poor. Any organic materials present in any kind of soil is really a very bad news, and this is why we sometimes will replace the organic soils or the organic or the sections of the organic soils with. So obviously, by looking to this question here, we can determine that the correct answer is, anybody can guess, tell me what is the best here based on our discussion. You'll find that we have organic here, we have silt, plastic silt, and the clay. This is an issue also. Silt and the clay, those are the fines, and so on. So, and always, I highly recommend you to read or go over all the four questions or the four, possible answers. And the four possible answers, always look for the best. Some answers, by the way, they are very close. Some answers, they are very close to each other, and we need to pick the best of the. Okay, so I'm looking for the best answer, the best answer. So this table could help you to answer this type of question, and I found this table is very good table, and I hope that okay. So this is something that I needed to be aware of. So obviously, any soil that has organic material is going to be a problem for me, and stability issue, compaction issue, and so on. Because um, stay away from any organic, and and this is opposite to what we eat. By the way, yesterday I went to Costco and I found that the organic food, okay, it has a certain section in Costco section, and all of you familiar with that. And the organic materials or organic food, okay, it is a little bit um, uh, sometimes double or triple the price of the non-organic food. So the bad news here for organic soil, but for the food is good. Okay, so I need to remember. So it's opposite what you pay at Costco. Okay, so opposite. So it is you pick the good stuff from Costco. Sorry, I'm not advertising here for Costco, by the way. I don't have their stocks either, so don't misunderstand me. Okay, just I tried to remember the word organic yesterday, and in relation to the word organic today. So this is something that okay. So please go over these equations. I have some problems here. So try to look to uh, um, the equation that we are going to use for the uh, um, computation of the E cells. This is a general equation. This is a general equation. The E cells, the equivalent single axis load, the initial ADT, the G, which is a growth factor. D sub D is called directional distribution factor, which is normally 50%, unless it is otherwise indicated 60-40 or 70-30. And D sub L, which is the lane distribution factor, we have a table. This is a percentage of the traffic will be using a specific lane. Okay, and they came up with a table, and we are going to see the D sub L. T is a percentage of trucks. T sub F is called the truck factor. This could be a problem, but it's a truck factor. Okay, this will give you E cells per truck. And finally, we multiply all this by 365 days a year. Okay, and this is what we are going to see. So the equivalent single axle load calculation, it could be a target for a question. Here in a simple figure illustrated here, what is a single axle, single tire, single axle, and this is a tandem axle, and there is some triple axle and so on. So I need you to be aware of that. Sorry, I saw one of you raising the question here, and probably I did not. Sorry, I got this. Focusing on studying. Sorry, on writing. Okay. Oh, you found the answer. That's good. Okay, good. Okay. Sorry. Sometimes I don't mean to ignore anybody, but so this is the equation that we are going to the equivalent single axle load. The ADT at time zero, or the initial, it's called initial. We put zero here to indicate this is a vehicle per day, VBD. Okay. Average daily traffic. Okay. The reason that we are using the time zero is um, uh, when you design a facility, either a local road or a highway or a freeway. So you start from when you design the job, like 2020, for example. You start to design the job January. Design started January 1/1/2020, and after that you hit with Corona. Oh my God! And everybody start working from home, and the things are getting slow. So probably you will finish the design in 1/1/2022. So you spend 2 years design. Okay, so 2021 and 1/1/22. So 2 years design. After you design the job and go through all the process of the design, you are going to advertise it and give it to a contractor to start the construction. Normally, there is some time from finishing the design and submitting and get the RTL ready to list and advertisement and award, all these things. I'm not going to talk about it. Just let's assume that you are going to start construction, okay, in 2022, okay. Let's assume that it is 1/3, okay, and maybe it is 1/3/25. It will take to construct this job. It takes about 3 years to construct it, to build it. 3 years, assuming that the job is complicated and a lot of traffic, and you need to traffic handling and all these things. And you open the facility open to public. When you open the facility in 1/3/25, 1/25, everybody start to use it. So should we use the ADT when we open the facility to the public, or we have to use the ADT for the future? No, we are using for the future. Okay, so when we design for ADT that 20 years or 30 years or 40 years nowadays, or even 60 years, by the way. We start to do some design for 60 years because the disruption to the public, because the volume will increase the moment you open the facility. There will be a lot of houses here and a lot of commercial businesses here and so on. A lot of business will start to build around the new facility. So we are expecting the traffic will increase. So in this case, we are expecting the so this is why we calculate E-cells. We are saying that ADT at time zero. What is time zero? Time zero is the first day you open the facility to the public. This is the time zero. This is ADT time zero. And after that, we multiply by something is called the growth factor, which is G. And we are using this equation, by the way, from the engineering economy. Based on the growth rate, 4%, 5%, the planning division or the planning department will tell you, okay, this area is expected to grow at a rate of 4%. Businesses and also the traffic will grow by 4% every year. So we increase the volume by a factor greater than 1 to account for the growth that will occur over the whatever the design year is. This, by the way, we call them design years. The 20 or 30 design year, okay, or design years. So this is what I needed to be aware of. So So this is the equation. We are going to go over the whole process of computing this, by the way, is very, very important. And I'm going to get a problem, which is um, the equation is repeated again here, that at the end here, I have a very good problem. I will go over it next time. Okay, so problem number 17 to 25, set of data uh, are given, or data are given here. And uh, and one book, by the way, I believe I got this problem from this book, if I'm not mistaken. Um, this is a book that I used it when I was teaching pavement design. Pavement analysis and design by Dr. Wang. It's a very famous book, and I'm sure that those who took the pavement uh, analysis and design class or pavement design class are familiar with this book. It's a very good book. I use it a lot. It has a lot of equations. The entire book is and in reference to H2 also, and so on. So I believe either this problem or something similar. Numbers are not the issue. The issue is the concept, how to understand the concept, how to apply the concept, and this is what I'm going to cover next time. I will stop here right now, and I will scan what I talked about today, and I will send it to you. Please read this chapter when we meet next time, chapter 4, not chapter 4, sorry, chapter 9 of the materials, because it's very, very useful chapter. It does have information related to pavement design, by the way. So this chapter, the one I sent it to you as a PDF this morning, and I scanned it and sent it yesterday. Even it came from the FE book, but the FE7, it's a very useful chapter, and you will, and also whatever I promise, I will. Um, so this will multiplied by G and multiplied by this D sub D, multiplied by lane distribution factor, we multiplied by T, uh, uh, and multiplied by track factor TF, sorry, TF times 365. Let me just make sure that I did not ignore any number, because as I get older, I get stuff mixed up or forget some stuff. And T sub F, yeah, T sub F and T D sub L G. Yeah, I think it's okay. Yeah, the equation is good. Okay, the equation. So this is the general equation to calculate the E cells, and in order to get the T sub F, which is a track factor, by the way, track factor, you need a TF, a track factor, and this is something that we need to get the LEF. So the LEF, the load equivalency factor, is going to be part of the computation of the T sub F. And we need to know how to do all these things, because this could be a problem by itself. And I heard that something like this was asked in the past to calculate the T sub F, the track factor. They will give you a set of information, and after that, he will ask you, what is the track factor? And you are going to see this, okay? So try to do your best, and I will do all my best. I will scan whatever I have right now, because I have to leave. I have to be exactly at 12 o'clock somewhere. So I have to scan this and send it to you first, and after that, I will rush very quick to my appointment at 12 o'clock, and after that, I have to come back at 1 o'clock to teach the surveying, not the surveying, sorry, the seismic. Oh, the seismic, by the way, if you would like to join me, if you would like to learn seismic, or it is the ID, you will go www.joinwebinar.com, which is available on the website, by the way, our website, but just in case. And the ID, you enter the ID. I still have 2 sessions, by the way, for this 719 049 035. Okay, so this is for the seismic class from 1 o'clock, seismic. Okay, so if you are interested, you are very welcome. It's free, nothing. You are not going to lose other than just, okay, nothing. Okay, so please do your best, and I will do all my best. Communicate with me, and I will do all my best to keep helping you guys until you pass this exam. But you need to do your part, and thank you very much for coming. Let me grab a few things here. Probably some of you was asking something, or they are saying something. Yeah, I will go over it next time. Okay, somebody's asked me, can you go over the shear moment diagram, the one I go over it yesterday, the one I gave it yesterday? Yeah, I will be glad to go over this next time, but I don't have it with me right now, so I have to dig in to see where it is in the binder. So I cannot really. So I really appreciate if you can do it, my friend. And when we meet next, we still have one meeting for the AM. Okay, the one that has a concentrated moment, and I have tons of problems like that. Okay, so do it in your own, and after that because if I go over it right now, I have to go over it again when I meet with the several bread group, because I have to be fair. So I prefer to go over it once, at least everybody get the maximum benefit. But and also I need to give you a chance to go over it. Okay, thank you very much. Okay, enjoy the rest of your day, and keep doing your best, and I will do all my best. Thank you very, very much. Bye bye.